Okay, so first a little bit about us. So I'm Steve Hudson. I'm a software engineer, Argonne National Lab. I've been there for about 7 years, but I've been HPC for about 20 years as a parallel programming specialist. And I've worked on all levels of parallelism in that time: vectorization, threading, multi-processes, MPI. And I kind of see ensembles as another level of parallelism. So at Argonne, I've been a developer on the package libensemble, which is an ensemble toolkit for running dynamic ensembles, where you may be, for example, running an optimization or some other model that is driving simulations. It could be AI. And libensemble, we pride ourselves on running portable heterogeneous workflows. So detecting and assigning CPUs, GPUs on NVIDIA, AMD, and Intel hardware. So we run a lot on Aurora, Frontier, Perlmutter. So that's me. And then we have William.
Yeah, thank you, Stephen. So my name is William Godoy, senior computer scientist here at Oak Ridge National Lab. And actually, full disclosure, I'm working with Rafael in one of the projects trying to connect the facilities, here, as you can see on the pictures, we Oak Ridge hosts Frontier and also the neutron science facilities like SNS and Hyper. About me, I'm coming more from the programming model side, and during the exascale computing project that many of you were part of and participated. So I work on different types of projects, like parallel I/O and applications, and have also work in industry, particularly at Intel. That was more than a decade ago. And currently, I'm involved in Oscar projects related to software stewardship and S4PST and PESO, in which SWAS is also part of the newly announced consortium for the Advanced Scientific Software, so CAS. So why I'm motivated in this topic? Because programming HPC is just hard. It's really hard. One of the things I also like doing is working with interns, and we realized that heterogeneity have added a steep learning curve. So and also because it's part of our mission. DOE doesn't play favorites. We have, in particular on the Oscar side, we have performance portability and heterogeneous architectures as part of our mission. And as you can see, there are products on the programming model side that DOE funds, right? Like Cocos, Raja, RNL got an R&D 100 recently, and one of the in-house products, Iris, to generate codes that run on multiple hardware. My interest, as you can see on recent years, is on this intersection between high productivity and high performance languages. Very proud that we had a best paper last year at SC Works. I see people from the community here. Thankful for the recognition. I'm trying the Julia language, which builds on top of LLVM for high performance computing. So we're going to talk a lot about that topic, right? How to standardize, how there are so multiple solutions, and more recently on how large language models can help on this HPC programming problem. So I attached some of the publications so people get to know what we've been doing the last few years. So, and it's been a pleasure to coordinate this with Steve and Steven. The last week we tried to put something that will call your attention. So, next. So, from our discussions, what has changed since 2 years ago feels like an eternity. The elephant in the room is large language models. That's what we all talk about, since ChatGPT came out. And then you have other foundational models like Llama, and it has become ubiquitous not only in computing, and our daily tech news updates. That's essentially what has been driving computing, and also from the vendor side, NVIDIA essentially won this. We are relying on this type of hardware. I think DOE make the right decisions to, use GPUs to reach exascale, so we are continuing seeing this trend now applied to AI. From our side, more on the HPC side, we have two exascale systems now delivered, Frontier and Aurora. And our funding models actually have changed. All this is new now. So ECP was a very unique opportunity, right? The exascale computing project kind of ended last year, so we are back to our old funding model. And we also added digital twins. I'm personally not an expert, but that's another term that we see in more and more, as computational resources like data and computation become more accessible, right? So, and that, yep.
Okay, so I'll mention something about the current challenges. So with the end of Moore's law, we've obviously gone to more heterogeneity, and that has been a real challenge for portability, making portability increasingly difficult. The proliferation of options. Can we find some standard solutions to the resource wrangling, for example? Something like Flux comes to mind, or the resource manager in LibEnsemble. I think we need to talk about how we can standardize these solutions. Workflows versus facility applications. So facilities have not always had workflows as a leading consideration. I think that's changing. Sometimes I've experienced large and varying overheads on certain systems. Sometimes things breaking on system upgrades, especially when I'm doing multiple S runs that are hitting the same node, for example. So I think we need a more proactive relationship between tools, the facilities, and the vendors. And the more we can keep the community involved with what's going on, the better. Energy costs has come up a few times. This is clearly an increasing concern. And fractured landscape, so we have these two worlds colliding of AI and HPC, and how do we manage that? And on this one, William, was it me?
Okay. Yeah. So, and then we discuss some potential solutions, but these are mostly our, part of our brainstorming, but we want to hear from you on, the breakouts, So, as mentioned, the list, incorporate workflows in the forefront, right? Of the not only on testing, but on the system design and the whole business of deploying the system HPC systems. As Steven mentioned, we need better coordination. We kind of do, but we as things evolve, we kind of try to put the workflow aspect at the forefront again. It's also more of a social problem and also a funding problem, So we have to enhance the communication across the different parts of the community. Maybe user training is one way to look at it, but we want to hear from the community on these aspects. Everybody has his own experience, right? So this is just the two of us. Efforts to enable standardization, something we mentioned, like maybe we're having an MPI moment, right? Like we realize that there are several solutions that share same merit, same value. Maybe it's time for them to talk and evolve, right? Understand how investments in AI, LLMs can help. I think DOE is funding some of the efforts on AI. There was being FOAs in that direction. We need to make those things our own, right? Like, this is a low domain data. We still need to figure this out. Accessibility is a big thing, especially for end users. I think technologies like that come to mind, like Jupyter, enhance a lot of this accessibility. Even Python, right? We recognize as a widely used language. But another thing that as I mentioned in my slide, I'm interested in this intersection: high performance, high productivity, modern programming, right? Where LLVM is a unifying force, right, at the backend compiler level. Most vendors now adopt some flavor of LLVM. but can we do that at the front end layer, right? You have attempts to do that like Numba inside Python or the Julia itself module, right? So can we get more out of this high level languages, right? And that's kind of like the history of computing. We try to add layers on top of, more low level abstraction, right? So.
So topics for discussion. So questions. So I want to ask people, how do you define heterogeneous arguments? So environments, because we may be coming at this from different angles. Is it running lots of simulations that are using GPUs? Is it, different workflow components? How are people thinking about this? And also asking you, what are your most critical issues? So we want to hear from you, and that can guide our discussions. So some of our topics: proliferation of tools. How do we aim to consolidate tools? Also the things like putting together a suite of workflows for testing. There's already, for example, the E4S suite that gets tested on Perlmutter, but can we standardize that more, and what's going on at the moment? And how do we help users in training users, helping users to use the tools? And I think we need to hear from people who are using different workflow tools currently and developers of those tools. So how do we make portable workflows using heterogeneous resources? Then, as William mentioned, potential use of AI, and which is also used in different ways in workflows. And what does heterogeneity mean for the IRI program? Challenges for remote systems, I think, automatically come into this. And also, I want to keep community activities going. So my proposal is something like regular virtual meetings, maybe once a month or something like that. So any ideas people have on that? If you're interested, come along to the heterogeneous breakout. Okay, thank you.